Welcome back. This is the second part of the lesson I just taught. I just got done teaching about how to get rid of a exponent using a square root sign. Well, we do that because those are inverse operations. And if it works one way, it should work the other. Just like when you have to add, how do you get rid of adding? Subtract. How do you get rid of subtract? Add. How do you get rid of multiply? Divide. How do you get rid of divide? Multiply. Now we're on the third new part of it, is how do we get rid of a exponent of 2? You do the square root. So how are we going to get rid of this square root to get x by itself? Why don't we use an exponent of 2, right? Because the square root and the exponent of 2 are inverse operations. So I'm going to square both sides to get rid. Now, since they're opposites, a exponent of 2 and a radical sign cancel out. X equals, and then we just evaluate. What is 9 squared? 9 squared means 9 times 9. Which is 81. Just a quick little PSA about it. If you guys are like, hey, I don't need to memorize these numbers, I don't need to memorize any of this math. Memorizing number facts will make you more fluent in math. Just like in reading, or just like in English, if you're reading a book and you don't know a word, yeah, go back, you can look it up, go in the dictionary, see what the word means, so you can better understand the material. But to know vocab of English is to be able to flow better, faster, and more efficiently through your work. Same thing with math. Just knowing the math facts is going to help you out. But now we move on to the next one. Well, we're still trying to get, let's get that. We're still trying to get this guy by himself. But that square root sign is directly affecting that x. To be able to solve for that, we got to get rid of something that is more detached. Because if you can detach the things that you can as you go, and you come back to what's directly affecting it, right? You want to eliminate anything that potentially has something to do with changing it. And that is that -4. So like we know, we always want to work backwards. We ought to get rid of -4. How do you get rid of -4? Why don't we add 4 to both sides, right? Add 4, add 4. So now we get the square root of x equals 36. Boy, I made this problem really big. I did it backwards. It doesn't matter. The math still works out the same. And how do we get rid of the squared sign? Square root sign, you gotta square it. Now, I goofed up. I meant to do it the other way. It doesn't matter. It still doesn't get you an answer. I don't know the answer to this, so let's calculate this right quick. You should get 100, and if we plug that in, that'll be right. 1,296. Sorry, I didn't mean to make it so big, but that doesn't matter. And then we move on to the next problem, which is an extension of this problem, right? They extend, it gets a little bit longer, it gets a little bit harder. Now we go to the next problem. Now, we have 3 operations. We have an exponent or a square root, technically counts as an exponent term. We have a multiplication, and we have an addition. Now, we always want to work backwards to solve for x. Because normally when you solve it, you would plug a number in for x, you'd use the square root, and then you'll multiply by 5, and then you'll add 6. Because that's how you do it when you use PEMDAS. But we're working backwards, so we're going to do the operation backwards. So, we got to get rid of this plus 6. How might we do that? Why don't we subtract it off both sides? So we get 5 square root x equals 16 minus 6 is 10. Same thing as before. We have a multiplication problem and we have a square root problem. Well, we got to do multiplication before square roots. So we're going to divide by 5 to get that by itself. We get root x equals 2. And then how did we get that root sign away? We do a square root. There's our answer. As you can see, it gets a little bit harder as we go through, but that's what math is. It builds off your prior knowledge. Let's get you a problem. Maybe, time out. You might want to look at that a second longer. Okay, now we'll get you a problem. Scroll up. Why don't we try this one? Why don't we try -3 square root x plus 12 equals, now I gotta plug a number in there for me. Boom, let's do that one. Try it out. School's over. Well, like we said before, to get the x by itself, we gotta get rid of anything detached from it and then work backwards. So why don't we get rid of this minus 12 from each side? And like before, we have a multiplication problem and an exponent problem. And we gotta get rid of multiplication first because you gotta work backwards from PEMDAS. And then we square both sides. Obviously, we'll get a lot of extra practice in, but this is just a little intro lesson to try to pick up what we know. Thank you for watching, and I will catch you guys later. Bye-bye.